Okay, so I've written down the parametric equations for Matthew's position. Let's talk about the parametric equations for the position of the ball as a function of t. So we're told that the ball's velocity is, I believe, 88 feet per second. Yes, okay. So the total distance that the ball travels, let's call it d, equals 88t. And that means the horizontal distance is, or excuse me, the horizontal position is, starts at 90 feet. So that's the starting position. So 90 plus the horizontal, well, it's 88 times cosine of 100 degrees times t. Let's see, find my train of thought. All right, so that's the parametric equation for x. Oh, I know what I was going to say. You might think, okay, Tony's over here at x equals 90, but the ball's going this direction, so it seems like, oh, you'd want to subtract the horizontal velocity of the ball. But the cosine of 100 degrees takes care of that, because cosine of 100 degrees is going to be negative. So what appears to be a plus sign is going to become a negative sign. So that's the equation for position of the ball in terms of the x-coordinate. And y is going to be, in this case, we're basically saying Tony is 0 feet tall. Tony has no height. We're assuming the ball starts at ground level. So it's simply 88 times sine of 100 degrees times t. So that's simple enough. So now we have all 4 parametric equations, or we could say we have 2 sets of parametric equations. And it's a little tricky problem because they want to find what is t when the distance between the ball and mat is at a minimum. So the final step is to come up with an equation that tells us, we'll use little d because that's what they use. Little d, the distance between Matthew and the ball as a function of t. Well, this just uses the Pythagorean theorem. And what they're saying is, let's just draw it over here. Here's Matt, and here's the ball at some point in time. And the distance, the total, let me draw this bigger. Here's Matt, whoops. Here's Matt at a certain time. Here's the ball at a certain time. And this ball has an x and a y coordinate. And let's call that x2 and y2. And Matt has a certain coordinate, x1 and y1. So this distance d is just going to be, using the Pythagorean theorem, d as a function of t equals the square root of x1 minus x2 squared plus y1 minus y2 squared. So, and they let you solve this graphically. So it's a little bit, I mean, there's lots of steps here. There's lots of numbers to manipulate. But here's x1, here's y1, and here's x2 and y2. again, you're dealing with lots of numbers, but you just plug x1 and x2 into this equation, and y1 and y2 into this equation, and solve it graphically to find the minimum. You just want to find the minimum of D.